Hello and welcome to section 6, which is find segment lengths in circles. There's one objective for today's video. We're going to calculate segment lengths in a circle when the vertex is inside or outside of the circle. So today's pictures or today's figures are going to look a lot like yesterday's figures because the vertex is inside or outside the circle. But this time, instead of calculating angle measures, we're going to calculate segment measures. We're going to jump right in with our circle formula sheet. For the segment formula, when the vertex is inside the circle, but not at the center, it's going to be part times other part equals part times other part. Make sure that you know that that x is a multiplication sign and not actually a variable x. These come from the same chord, and then these two segments should come from the same chord. Now, I know that this is not a specific formula whatsoever, so I think that we should just look at an example. So, look at example 1. We see that we have a vertex inside the circle, Q, and it's not at the center. We have to find x, which is a segment. Now, we need to look at each chord at a time. Let's look at chord TR first. One part of the chord is from T to Q. So that's going to be 3 times. The other part of the chord is from Q to R, which is 6. So 3 times 6 equals. Now we're going to look at chord PS. One part of the chord is from P to Q, which is 9, times. The other part of the chord is from Q to S, which is the part that we're calling X. And then we just solve. 3 multiplied by 6 is 18. 9 multiplied by X is just 9X. If I divide by 9, I get x equals 2. That's it. So you just have to remember to look at one chord at a time and then compare to another chord. Okay, time for you to try. Pause the video and try this one on your own, please. Good luck. Okay, I will tell you should have gotten x equals 4. When you come to class tomorrow, I will be checking to make sure that you have the work and the correct answer for this problem. So, we're going to move on to some definitions. First, looking at CT, this is a secant because it intersects the circle in 2 spots, once at A and once at T. This part that's outside of the circle is called the external secant. So it's the secant, but it's the part outside the circle. And then CS, you should already be able to label that because we learned that in the first section. It's a segment, intersects the circle once. This is called a tangent. That's just a little vocab for you. If you flip the page, we're now going to jump to our next formula. Okay, so this formula is the segment formula when the vertex is outside of the circle. So the formula for this one is outside times whole equals outside times whole. This comes from the same segment. This also comes from the same segment. Again, very vague formula, so let's just illustrate it. Looking at example 2, it says find the value of x. Well, our vertex is outside the circle, D. So I need to look at one segment at a time. I'm going to start by looking at segment FD. Okay, so it says outside, that's this part, the external secant part. So it's going to be 11 multiplied by the entire segment. So that's all of FD. So that's going to be 10 and 11, which is 21, equals, now I'm going to look at my second secant. Okay, so the formula says outside again, which is the GD part, 12, multiplied by the entire segment, HD, which is going to be x plus 12. And then I need to simplify. Okay, so solving, the left side becomes 231 equals, the right side becomes 12x plus 144. If I subtract 144, I get 87 equals 12x. So x equals 87 divided by 12. That simplifies to be 7.25, which is the same thing as 29 over 4. Okay, so let's look at another example. We're going to do one more together, and then you're going to do 2 on your own. So this next one, it's called jumping the shark. It says, you are standing at point C, about 8 feet from the edge of a circular shark tank. The distance from you to a point of tangency on the tank is 20 feet. Estimate the radius of the tank. Okay, so you're standing at point C. You're standing at a point outside of the circle. The vertex of the angle is outside of the circle. So it's going to be part outside times whole equals outside times whole. Let's look at our first segment, the BC. The part that's outside is 20. And then the whole is still 20. That's because this segment is a tangent. So anytime that the segment is a tangent, you're just going to be using the same segment twice. Now let's look at our other segment. This is a secant. Okay, in this case, the outside part is right here. The outside part is 8. And then this, DC, is the entire segment. So that's going to be 8 plus R plus another R. Okay, on the right side, this becomes 400. On the left side, 400. Right side, it's 8 multiplied by 8 plus 2R. When I distribute that 8, I get 64 plus 16R. Subtracting 64, I get 336 equals 16R. Dividing by 16, I get R equals 21 feet. So the radius of the tank is about 21 feet. Okay, again, here are the 2 that you're doing on your own. I would like you to pause the video and do both on your own, please. Good luck. Okay, let's see how we did. In the first example, vertex is outside the circle. So I'm going to do outside times whole. Looking at the first secant, the outside part is 15. The whole is going to be 15 plus 3x. Looking at my other secant, the outside is 20. The entire is 20 plus x. Distribute on both sides, I get 225 plus 45x equals 400 plus 20x. If I subtract 20x, I get 25x equals, subtracting 225 from 400, I get 175. So then I have x equals 7. Hopefully that one went well for you. Now for the second example, you should have gotten x equals 4. If you didn't, you need to go back and find your mistake. When you come to class tomorrow, I'm going to be making sure that you have all the work completed with the correct answer. If you have any questions, feel free to ask tomorrow. Now, let's flip to the next page. Okay, so we have 2 more. These are definitely 2 more difficult examples, so we're going to do them together. They're not difficult because of the setup, but difficult because of the solving. Example number 4 says calculate the value of x in the figure. Okay, I have my vertex outside the circle. So it's going to be outside times whole equals outside times whole. Looking at my first secant, the outside is x minus 3. The whole is x minus 3. Add 2x plus 9. Right side, or the right secant, the outside part is 9. The entire part is 9 plus 3x plus 2. Okay, simplifying the left side, x minus 3 cannot be simplified. I have x and 2x, which is 3x. I have negative 3 and positive 9, which is going to be positive 6. On the right side, I have 3x plus 9 combines with 2 to become 11. Okay, now here's where I'm going to have to draw a box to multiply these. Or some of you use that other term that I'm not going to say. 3x and x is 3x squared. 3x and negative 3 is negative 9x. 6 and x is 6x. 6 and negative 3 is negative 18. So the left side really is 3x squared. And then negative 9x, positive 6x becomes negative 3x. Then I have minus 18 equals. When I distribute the 9, I get 27x plus 99. Okay, I'm going to move everything over to one side. So that means subtracting 27x, subtracting 99. So I have 3x squared minus 30x minus 117 equals 0. Okay, anytime that you have an x squared and an x, you're going to have to factor. I'm going to start by factoring out of 3. Everything here is divisible by 3. When I factor out of 3, I get x squared minus 10x minus 39 equals 0. This is going to make my factoring a lot easier since I was able to factor out of 3. Now, all I'm looking for are two numbers that multiply to negative 39 and add to be negative 10. The only factors of 39 are 1 and 39, which certainly don't add to be 10, and 3 and 13. That sounds better. Positive 3 and negative 13 are going to add to be negative 10. So this factors to be x plus 3, x minus 13. And it's still set equal to 0. Now I set both equal to 0, so x plus 3 equals 0, x minus 13 equals 0. I get x equals 13, x equals negative 3. Now looking at my figure, I need to make sure that both make sense. Well, when I substitute in negative 3, I have negative 3 minus 3, which is going to be negative 6. It does not make sense to have a segment that's negative 6. So negative 3 is not going to work. Our only answer is going to be positive 13. So this was a little bit of a review of factoring. Hopefully it jogged our memories a little bit. The next example we have is also going to jog our memories, so prepare yourself. So in this case, we have a secant, wx, and we have a tangent, wg. Looking at our tangent first, the outside is 5, the whole is also 5. Looking at our secant, the outside is x, the whole segment is x plus 4. So I have 25 equals x squared plus 4x. If I move the 25 over, so I subtract 25, I have 0 equals x squared plus 4x minus 25. Okay, so again, we have an x squared and an x term, so we need to try to factor. So I need to think what two numbers multiply to negative 25 but add to be 4. Well, the only numbers that multiply to 25 are 1 and 25 or 5 and 5. Neither of those cases add to be 4. So this does not factor. We have to use the quadratic formula. So hopefully you remember the quadratic formula. If not, I'm going to write it down. You probably learned a song for the quadratic formula last year. I'm not the best singer, but in order to help us, I will sing it for us. So we have x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. That was supposed to be Pop Goes the Weasel. I understand my voice is not that good. But this is the formula. So b is what's in front of the x term, a is what's in front of x squared, and c is the last term. So in this case, if b is 4, the opposite of b then is going to be negative 4, plus or minus the square root of b squared, so 4 squared minus 4 times a times c, all over 2a. In front of the x squared, there's not a number, so it's understood to be a 1. Okay, so now we got to simplify. I have x equals negative 4 plus or minus the square root. 4 squared is going to be 16. Negative 4 multiplied by 1 multiplied by negative 25 is going to be positive 100. That's because I have this negative 4 and then negative 25. This is all over 2. Okay, so this is negative 4 plus or minus the square root of 116 all over 2. Before I do anything else, I have to simplify that square root of 116. So 116 is 4 times 29. 4 is 2 times 2. 29 is left over, it doesn't break down. So I have x equals negative 4 plus or minus, a 2 comes out, 29 stays under the root, all divisible by 2. Not done yet. Negative 4, 2, and 2 are all divisible by 2. So I'm going to divide them all by 2. So I have x equals negative 2 plus or minus 2 divided by 2 is just 1 root 29. Okay, so this gives us two answers. Negative 2 plus root 29, negative 2 minus root 29. Okay, if I get decimal approximations for both of those, I get about 3.39 and about negative 7.39. Now looking at our figure, negative again doesn't make sense. So this is my only answer, the negative 2 plus root 29, which is about 3.39. If you don't remember this, if you don't remember the quadratic formula, that's totally fine. At a minimum, I expect you to be able to set up the problem. We'll review a little bit more of this in class, and this was just to start jogging our memories so we can remember some of that stuff that we learned last year in algebra. That brings us to the end of our video. Today's objective was to calculate segment lengths in a circle when the vertex is inside or outside of the circle. So when the vertex was inside of the circle, we only did 2 examples. You multiplied 2 parts and set them equal to the 2 other parts. When the vertex is outside, that was a little more complicated. It was part times whole is equal to outside times whole. If you flip the page, there's a few more examples. Okay, these examples are if you would like to watch them. I will start by giving you the answers, so you can try them on your own and check your answers. Or you can just work through them with me, whichever you prefer. Okay, first for the answers. For extra number 1, you should have gotten x equals 5. For extra number 2, you will get x equals 6. For extra example number 3, you will get x equals 12. And extra example number 4, you will get x equals 8. Now I'm going to go through them. Watch the ones that you would like, or watch all of them. Okay, so extra example number 1, we notice that the vertex is inside of the circle. Looking at the first chord, I'm going to multiply the 2 parts. So I'm going to have 12 multiplied by x. Then looking at the second chord, I'm going to multiply the 2 parts. So x plus 5 multiplied by 6. Simplifying, the left side becomes 12x. The right side, when I distribute my 6, becomes 6x plus 30. If I subtract 6x, I get 6x equals 30, so x equals 5. Extra example number 2. This time I'm going to notice that the vertex is outside of the circle. So this is going to be outside times whole is equal to outside times whole. Looking at my first secant, the outside is 5. The whole is 5 plus 3, which is 8. Looking at my second secant, the outside is 4. The entire is 4 plus x. Simplifying, 5 multiplied by 8 is going to be 40. When I distribute my 4 on the right side, I get 16 plus 4x. Subtracting 16 from both sides, I get 24 equals 4x, and then x equals 6. Okay, extra number 3. Again, vertex is outside of the circle. So it's going to be outside times whole is equal to outside times whole. For the tangent, the outside part is x, and then x is still the whole part. Looking at my secant, the outside is 9. The entire is 9 plus 7, which is going to be 16. Okay, hopefully you remember that x multiplied by x is x squared, not 2x. And then 9 multiplied by 16 is 144. Now we need to take the square root. Remember that when you take a square root, you get a positive and a negative answer. So I'm going to get positive and negative 12, because the square root of 144 is 12. Now looking at our figure, the negative 12 doesn't make sense. I can't have a negative 12 length. So we just stick with x equals positive 12. Okay, and then extra number 4. This is this is definitely the most difficult out of the 4 extras. Again, vertex is outside of the circle, so it's going to be outside times whole equals outside times whole. Looking at the tangent, 20 is both the outside and the whole, so I'm going to have 20 times 20 equals. Looking at the secant, x is the outside and the whole is x plus 42. Okay, on the left side, 20 times 20 is 400. On the right side, once I distribute my x, I get x squared plus 42x. Subtracting 400, I have 0 equals x squared plus 42x minus 400. Okay, and now I have to factor. I'm looking for two numbers that multiply to negative 400, but add to be 42. So multiply to negative 400, add to be 42. While I have negative 10 and positive 40, those don't add to be 42. If I flip them around, 10 and negative 40 still don't add to be 42. It's 30 and negative 30. I have 2 and 200. That's not going to work. I'm going to have 4 and 100. Those aren't going to work. So I need to keep going. Eventually I reach 50 and negative 8. Those add to be 42. So this is my winning pair. My factoring then becomes x plus 50, x minus 8. So again, 50 and negative 8 are going to multiply to negative 400 and add to be 42. Setting both equal to 0, I have x plus 50 equals 0, x minus 8 equals 0. This gives me x equals 8 and x equals negative 50. Again, I need to look at my figure. I can't have a length of a negative, so negative 50 is not going to make sense. The only answer I'm left with then is x equals 8. Okay, thank you for going on. Hopefully this helped you and gave you a little more of a solid understanding. Please bring any questions that you have to class tomorrow. Goodbye.